Colby, math.com.
We're practicing with divisibility rules. And problem 16 on the back asks you to create a UT diagram to list factor pairs and then list all factors in ascending order. So we learned today how to identify all factors with a UT diagram. So the first factor of any number would be 1. 1 is a factor of every number is divisible by 1, and so 1 multiplied by 216. The next factor we would check would be 2, and 216 of course is divisible by 2 because it's an even number, and the digit in the ones place is a multiple of 2. 2 multiplied by 108. For divisibility by 3 we find the sum of the digits. 6 plus 1 plus 2 is 9. And 9 is a multiple of 3, so 216 is a multiple of 3. It's divisible by 3. And when I think of 216 being divisible by 3, I like to break it up into 210 and 6, because 210 is 73s and 6 is 2 3s. So it's 3 multiplied by 72. To determine whether 216 is divisible by 4, we consider the number formed by the tens and ones digits, which is a 16. And if that number is divisible by 4, then the whole number is divisible by 4, and of course it is. In order to get 4, I would need to double this 2. And if I double that factor, I need to halve the other factor, which would be 54. That doubling and halving strategy can help you find a lot of these factors when you're using the UT model. 216 is not divisible by 5 because the ones digit is not a 0 or a 5. 216 is divisible by 6 because it's divisible by both 2 and 3. And I'm going to use the doubling and halving strategy again with 3. I can double 3, so I need to half 72, which is 36. Is 216 divisible by 7? There is a rule for divisibility by 7, but we talked about in class it's a lot easier to just check. 3 sevens is 21. Subtract to get a difference of 0, bring down the 6. And so of course I'd have a remainder of 6. And so it's not divisible by 7. Is 216 divisible by 8? It is because, well, the rule for 8 is consider the number formed by the ones, tens, and hundreds digits, which for a 3-digit number is not helpful because we would still need to consider the entire number. But the reason I knew right away it's divisible by 8 is I see it's divisible by 4, which means it might be divisible by 8. But the other factor pair for 4 is 54, so we can use the doubling and halving strategy again. Why don't you go ahead and do that, and then also continue on to try to find the other factor pairs for 216 during the pause, and then come back and see how you did.
Paused.
Using the doubling and halving strategy for 8, we'd be doubling the 4 and halving the 54, so 8 multiplied by 27. 216 is divisible by 9 because 6 plus 1 plus 2 is 9. It's the same rule for 3, except here the sum has to be a multiple of 9. So I could triple the 3 to get 9, which means I would need to third my 72. That's tripling and thirding. That would give me 24 here. 216 is not divisible by 10 because the ones digit is not a 0. 216 might be divisible by 11. Let's check. If we consider the sums of alternating digits, 6 plus 2 is 8, and then this is just 1. 8 minus 1 is 7, and that's not a multiple of 11, so 216 is not divisible by 11. 216 is divisible by 12 because it's divisible by both 3 and 4, so I'm just going to double my 6 to get 12 and half my 36, which is 18. 216 might be divisible by 13. I need to check it. 6 13s is 72. 7 13s is 91, so that's not going to work for 13. I don't need to check 14 because it would need to be divisible by 7 to be divisible by 14. I don't need to check 15 because this is not a multiple of 5. I don't need to check, well, I do need to check 16, but I see that if I double my 8, I cannot half my 27, not and get a whole number factor in any case. So 16 doesn't work, and I don't really need to check 17 because I know 17 squared is 289. And if it were not for anything other than squared, I already have 18 here. There can't be anything higher than 17 or 18 on the other side. And so that's how we know we're done. So we've got the t. The u would look like this with an arrow, and then that lets you list your factors in ascending order. You start up here with the 1, and you work your way down and then follow the arrow, follow the u and the arrow to the 18, and then work your way up to list the rest of the factor pairs. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 27, 36, 54, 72, 108, and 216. Now I gave an example on the front of what's expected on the front, but just to be sure you don't end up having to do a ton of extra work on the front. It's asking you to check divisibility by certain specific factors, divisors. And so if this problem were on the front, or I'm only asking you on the front to check divisibility by 2, 3, 4, 5, 6, 8, 9, 10, 11, and 12. So if this were one of the problems on the front, your answer would be 2, 3, 4, 6, 8, 9, and 12. Okay, I hope that helped. I'll see you tomorrow.